Hey everyone, and welcome to the Retro channel, and today we're going to be checking out this Atari 7800. This was sent over by Visi from the Netherlands, and it's a little bit broken. The case is a little bit messed up, and it also doesn't work properly. The inbuilt game, which is Asteroids, doesn't seem to run. However, it does seem to work with the Atari 7800 cartridges. So a bit of an odd one. I don't know what's going on in here. And looking through my box of spare parts, I don't have a 7800 power supply. However, I did find some controllers and some 2600 games because the 7800 is also backwards compatible with the Atari 2600 games. So at least we can test some of those things out. And if it comes down to it, I can always pull out the other 7800. In fact, I probably will do that because I don't know if that one works back there either. So I'm pretty sure we can get at least one working 7800, but I guess there's only one way to find out. This video is sponsored by PCBWay. PCBWay are your one-stop shop for PCB prototyping and assembly, CNC machining and 3D printing, plus a whole lot more. They're also having their 9th anniversary promotion where you can score yourself a number of free coupons. So why not check out PCBWay today, and we thank them for sponsoring this video. So let's take the cover off this, which like I said is mostly broken, but I think there is one or two screws still holding it together, so we just need to pull them out. That one doesn't feel right. That might be it. And this is a PAL-B model, serial number X218513535, Atari Corporation, Sunnyvale, California. And there's some bits of plastic already falling out. Oh yeah, and the front is broken as well. I'm not going to worry about the case damage at the moment. There's a little bag of broken bits. We'll just put all that aside. Let's hook up the bench power supply. At least I can power this thing up and we can have a look and see if the behavior's changed at all. So it takes 9 volts DC, and I believe the shield is going to be connected to the negative rail, which was not that one. So the right hand side of this power plug is our ground, and that means the left hand side, which was connected to this ferrite bead here, is our positive rail. So I'm just going to clip these probes, clip these leads onto those points. And with any luck, this power LED should come on, which it does. Now, these do only have RF outputs, so we're just going to hook this up by RF to my little janky test display. I'll worry about, you know, composite mods and that kind of thing later. Let's just see if we can get this working properly first. So with any luck, it should still be tuned in. Yes, it is. And that's what we get, just a weird flickering display and some strange audio. But if I put the 7800 cartridge in, it should power on. Yep, there we go. So I'm guessing that it's a fault with the internal ROM, so I think that's the best place to start. Let's get this RF shield out of the way. Before we do that, let's just test a 2600 game, see if it does the same thing. It's booted into Asteroids, and it is drawing a lot of current. The bench supply is going into overcurrent mode. Something is certainly cooking. It's drawing 1 amp at 9 volts, but yeah, it's brought up Asteroids. That's crazy. And the reset button is working. So okay, let's try a different, oh, broken. Well, the other cartridge doesn't say broken on it. Hopefully these are not all broken. Bringing up Asteroids again. I'm sensing a pattern here. Oop. Could just be a bad connection. That game might actually be broken. And we're getting nothing from that either. So 2 of these games caused the system to boot to asteroids, which is weird. And the 7800 game boots to the 7800 game. So maybe the ROM isn't bad. Asteroids. So we have a system that boots to the internal ROM when a 2600 game is inserted. It boots to a 7800 cartridge when a 7800 cartridge is inserted. And without a cartridge where it's supposed to boot the internal ROM, it just hangs. Yes, both these cartridges draw a lot of current when inserted. I don't actually know if any of these work because I haven't bothered testing them. I just assumed that at least one of them would do something. And yeah, they do, but not the behavior that I expected. So let's whip off this RF shield and just take a look underneath. So it's all pretty basic inside. There's a big filter cap near the power supply here, and it looks like it's a linear jobby. There's a 7805 there. Apart from that, nothing too exciting. A little bit of 74 logic here. I'm not sure what these major ICs are just yet. I'm guessing that's going to be the ROM. That's some SRAM, a bit more logic. Just judging by the size of it, I think that is the Maria chip, which is what makes the 7800 a 7800. And that could be the CPU, which is based on a 6502, but yeah, I'm not 100% sure which one of these is the CPU. One of them is going to be the video chip from the 2600, the TIA or Tia Maria. And one of these is probably a input-output kind of thing. But looking closely at the board, I can see there are signs of rework. There's little bits of fresh solder dotted around all over the place. So I think we should pull this board out entirely, check the underside. There's the rest of the RF shield. There's definitely been some work done around here, over here. There's a weird bodge where the power LED is. There's some signs of work over here, but it doesn't look like all the pins on these ICs have been touched up, only certain ones. So that's a little bit odd. Maybe there were some bad solder joints that somebody reflowed. But yeah, even on the top side, there's signs of work being done. So don't know, maybe I'll just closely examine this, make sure there's nothing that's been bridged and no bad solder joints that I can see. So I couldn't spot any broken solder joints, but I did see a couple of solder whiskers just hanging around. So I've given the board a good scrub and it's looking a lot better. It still doesn't look perfect, but I can definitely see that everything appears to be good here. So let's boot this up again. Let's just see if the behavior's changed at all. I somehow doubt it, but it's worth checking, I guess. Plug that in there. Yep, we are still getting just random behavior. No change there. Okay, I might just pop out this, which appears to be the ROM IC, just clean up that socket just to make sure we're getting good contact there, but I don't think it's going to be this IC. Legs look perfect. Socket looks good. I guess we should do the cartridge port while we're at it. I think the 7800 cartridges have more contacts, so let's just do a bit of that. So it appears that whatever controls it booting into 2600 mode, 7800 mode, or the internal ROM seems to be a bit iffy. I'm still not 100% sure on this ROM chip, so we might pull out the other 7800 and just swap these over, see what that does, assuming the other one works. So this is one that I picked up a little while ago and I'm yet to test it. So let's open this thing up because we need to connect power to it. Well, there's certainly a lot more information on this label, all this FCC stuff. Serial number A193, or it could be 198, 5004976. No idea which one is newer or older. I guess it doesn't really matter. Okay. Oh, the RF shield certainly looks a lot better in this one. Oh. That's not good. I wonder if they're set to the same channel. No, I don't think they are. That should be the same channel. But doesn't boot every time? Or is this just not locking onto the signal? Ah, there it is. Alright, so it does work. The tuning on these two machines must be just slightly different, and this thing just blanks the screen if it doesn't get a good signal. Yeah, that's what's supposed to happen without a cartridge. Ball blazer works. Wonder if one of these actually works. Asteroids. So maybe these cartridges are actually bad. Yep, really doesn't like Kung Fu Master. And it doesn't like Mega Mania. Neither do I. Right, so it does seem like I have a bunch of bad 2600 cartridges, but there is some different behavior going on between these two. So, yeah, without a cartridge, this does what you'd expect. It boots into Asteroids, but it takes a bad 2600 cartridge in order to boot the other machine into Asteroids. It's a little bit strange. I'm still thinking it's probably, I guess, some selection logic, but let's pull this RF shield off, see what we've got underneath. Okay, looks more or less the same, a slightly different color maybe, but that's about it. The ROMs do look different. This looks like an EEPROM. It says OS with Asteroids C300558001B 7800 TSC, not NTSC, just TSC/PAL. And there's a date of something 2189. So the actual ID number, I guess, that Atari uses does actually match between these two. So let's just swap them over, see what happens then. So we've got the working 7800 with the ROM from the non-working 7800. Let's see, should get Asteroids. Should. It's drawing about 600 milliamps. So that's normal. Ew. We get some weirdness. So maybe this ROM is bad. Yeah. It's doing the thing that it did in that machine. How strange. So because this has Asteroids built in, and that seems to work sometimes, and it's also got the OS ROM built in, maybe there's just some slight corruption with the OS ROM that means it's not selecting the right, thing to boot from. I guess that's possible. Throw in ball blazer. Drawing 600 milliamps, but we're getting nothing from ball blazer this time. Oh, that's really strange. What are the chances that it'll boot to Asteroids with 2600 cartridge? No. You're just drawing that 1 amp with a 2600 cartridge. Well, surely this ROM is bad. I think that's the first thing we can be certain of. Yeah, boots straight into Asteroids. All right, let's try our good ROM in the other machine. All right, we're tuned to the right channel. This does that, yep, it's expected. And with our good ROM, we should get Asteroids. And with our good ROM, we should get Asteroids. Okay. And ball blazer doesn't work now. Right. Is this going to give us Asteroids? No. So there does seem to be an issue with the ROM from this partially working machine, but well, the behavior kind of switches when I switch ROMs between these two. What does that mean exactly? Well, seeing as this is an EEPROM, let's pull it out, put it in the Mini Pro, read back from it, see if it matches a ROM image, if I can find one online. I think that's the way to go. All right, so I've got the Atari ROM in the Mini Pro. Let's just read it back. And looks to have stuff in there, so that's always good. Now, I did find a couple of random ROM files on the internet, so we can try and load one of those in. This one looks close, but it's 001A, whereas this is 001B, so I don't think that's going to match up. Maybe we'll try this. Verify. Verify result successful. All right, so this is the matching ROM. Wonder if the 001A also verifies successfully. Surely not. There is a difference. There is a lot of differences. 6,735 of them. All right, that's cool. We've got BIOS Atari 7800 Europe. Seems to be the matching ROM. So it does verify against this EEPROM. Let's try this Atari ROM, because surely it's going to read just as a 27C128 as well. Let's go verify. Pin detect error. It could just be bad contact in this socket. No? Okay. It does not like the Atari ROM. Surely these are just interchangeable, right? Right? Oh, now I'm more confused. All right. Need to take a breather. Okay, so I did a bit of searching online to see if I could find out how these ROMs might differ, and I came up with pretty much nothing. However, I did find the schematics, which also don't seem to help. They list a couple of jumpers on the schematics, W1 and W2, but looking at both these boards, I did manage to find W2, which is under this jumper link here. It looks like a resistor, but it's just got one black band, so that's just a 0 ohm jumper link. However, I couldn't find W1 anywhere. Another thing I spotted though, there is a difference with these two jumper links. So we've got W5 and W6. On this board, W6 has a link on it, and on this one, W5 has a link on it. And on the schematics, I couldn't find any mention of W5 or W6. So I'm not exactly sure what these schematics are for, but they don't seem to match up to these boards. And they seem to be the only ones for the PAL machines available online. So schematics are kind of useless, but we can manage to trace these jumper links to pin 22 of the ROM IC. So obviously this one goes through W5 and off somewhere else, and this one goes from pin 22 through W6 and off to somewhere else. So at least I know that there is a difference between these boards, and that may explain why one ROM will work in one board and not in the other. So what I'm thinking is just swap these links around and see if the behavior changes. So all I've done here is just move this from W6 to W5. This end is just connected together. So it's the same point here that connects back to pin 22. We've just changed the endpoint through this jumper link. Let's see if that makes the EEPROM work properly with this board. Okay, so we're now getting that weird behavior with this EEPROM. What's a bet that Ball Blazer is going to work? And it does. And one of these should bring us into asteroids. It does. All right, so these ROMs are actually performing the same function, and it appears that the original ROM here is still good. It's just that the board layout is a little bit different depending on whether you've got a regular EEPROM in there or the original Atari ROM. You just need to change that jumper. So, just to be 100% certain, I'm just going to swap the jumper link on this board. Okay, with that link swapped, in theory, this original EEPROM should now work in this, what seems to be a fully working machine. Yep, there it is, we have asteroids. So this does appear to be working as expected. Yep. And goes back to asteroids. There is almost definitely something wrong with these 2600 cartridges. So it looks like the theory of a bad ROM turned out to be incorrect. So I've replaced the jumper links back to how they were and put the original ROM back in this board. I think next we might swap over the Maria chip from these boards just to make sure that there isn't an issue with that. It's the only other thing that's socketed on both these boards, so it's an easy way to rule that out. So I got the exact same result with both boards swapping the Maria chips around, so definitely not an issue with the Maria. It's not going to be an issue with the OS ROM, that was just a little jumper that we needed to change. So it looks like this is definitely some kind of cartridge selection, internal ROM selection logic. So let me have another look online, see if I can figure out how that is supposed to work on these machines. So after a bit of a look online, I couldn't find a huge amount of detail about the 7800, but I did find this document on Atari Age, so I'll link that in the video description. But it mentions that U11, which is the 74LS174, and U12, which is the 74LS32, both control the bank select or the cartridge select logic. So I think it's best that we start with those two ICs, see if we can spot anything weird on the oscilloscope. So I've got the Atari powered on without a cartridge, so let's just have a look. This is our 74LS32 and this is the LS174. So let's just start off with the 32, which is an OR gate. And that looks like our clock signal, 1.78 megahertz. So without hooking up multiple probes to this thing, it's not going to give us a clear answer, but it should be good enough to tell at least if something looks out of place. So our first two pins are our first set of inputs into an OR gate, and then the third pin is the output of that. And then it does the same. So pins 4 and 5 are the next inputs, and then the outputs of those is pin 6. So seeing as we've got a high on pin 5 that's just staying there, pin 6 should also just be high, which it is. And then we've got going from pin 13. So this is another set of inputs, so we've just got a high there. Doesn't matter what the other one's doing because we're just going to have a high on the output. That looks correct. And then there's one more set, so there's a low there and a high there, so we should have a high on that output. That seems to be correct. Let's look at the 174. The 74LS174 is a hex flip-flop. So there's 8 inputs and outputs, and they're controlled off what looks to be a clock signal on pin 9. So whenever this pin transitions, that will change the whatever's on the input to the output. I think that's how that works. So on this case, pin 3 is our first input and pin 2 is our first output. But seeing as this clock pin is just sitting high, we're not going to see any changes between input and output happening. So these do look a little bit weird. It looks like it is trying to transition to something else, but isn't actually happening. And we're seeing a lot of high signals. I'm curious to know if this clock signal actually does something when we first power on. There might have been something there. Let's go to single shot. It's hard to get it in single shot because it's catching the rise when we first power it up, which is that. So what I've done is note the behavior of the 74LS32 and the 174 on our working board. That way we can compare what's going on there to what's going on with our non-functioning board. Maybe we'll see something obvious from that. There's our clock signal as expected. And yeah, straight away the other board has activity on pin 2. This one is just sitting high. Same with pin 3 and 4 and 5. It's hard to tell if that's the problem though, because the outputs do match what we're seeing on the inputs. So it is working like an OR gate. The problem is most of the inputs are just stuck high, which isn't the same behavior as the other board. Let's have a look at the 174. Yeah, so I saw normal activity on pin 3 of the working board, but on this board, it seems like whatever pin 3 is, it's an input to this gate. It's just kind of stuck high, but it is trying to fight to go low. So it seems all these ones that have activity on our working board all look like this on our non-working board. Something isn't right. Question is it whatever's feeding these pins, or is it this logic IC itself pulling everything high? So looking back at the schematics, which I still don't fully trust, pins 3, 4, 6 and 11 are all data inputs. So data line 0 up to data line 3. So I've put the ball blazer cartridge back in just to see if they're now working as expected. Surely they are. Yeah, there we go. Yep. Yeah, so they all have normal activity, which is what you'd expect, because if the system's running with a cartridge, surely those data lines can't be stuck high all the time. So I've quickly gone through the repair flow chart for the 7800, and I've made it all the way to the end. But I don't really want to follow the instructions for that one. So let's press on, see if I can figure this out myself. So it would appear without a cartridge that nothing's really being selected. The chip select lines that come off the Maria all are... Now, what's going on with that? Well, that's weird. So this is pin 22 of the Maria. So you can see it starts off at 3.77 volts. And then give it a few seconds. What's going on there? Drops down to like 650 millivolts after about 5 to 10 seconds of power on. According to the schematics, pin 22 is address line 11. So address line 11 sits high for a while, and then after 5 or 10 seconds drops to low. but gradually. What? So it appears that after a while, all the data and address lines just go weird. It seems to happen more often as the system warms up. So at the moment it's stable. Here it goes, starting to drop. And this happens all the way across the data and address bus. It seems that once these chips warm up, weird things just start to happen. Look, it's almost booted this time. Almost. But it seems to be pretty inconsistent, although temperature does seem to affect it. So what I've been doing is just warming up the CPU. So if I warm it up to about 80 degrees Celsius, you'll see that it happens a lot quicker. So almost instantly from power on, it'll drop low. So I figured, well, let's check the freezer spray. So can of freezer spray. And see, it's always dropping low almost immediately. And if I freeze it, it'll stay high until the CPU warms back up. Looks like it's still a bit warm, but it doesn't go in the reverse direction. It's only after a power on. So if I keep the CPU cold, that will stay pretty much high all the time. And it only seems to happen on the CPU. Now, I did break out the thermal cam and had a look at the temperatures of the CPU on this board versus the CPU on the other board, and they're pretty similar. This one gets a little bit hotter after a while, but nothing major. And I don't really, I didn't even bother looking at the data or address buses, because when a cartridge is in there, well, the 7800 cartridge, the system seems to work just fine. So surely it was going to be cartridge select logic. But then I started thinking, well, maybe it's just a duff CPU that, once it heats up, just does weird shit. But that still doesn't explain why the CPU always works regardless if it's hot or cold with a cartridge inserted. So I was just about to pull out the CPU, and then I thought, well, it's all down to the cartridges, isn't it? I mean, the 7800 cartridge works all the time. The 2600 cartridges that don't actually work, but when they're in the system, boot to asteroids. So is it just the cartridge port all along? So here's our cartridge port along the back. Now all these pins should go to different data and address lines, along with, I think the clock signal runs out to here, and obviously power and ground. So in theory, none of these should have a connection, and that one does, as does that one, and that one, and that one. So there are short circuits across the cartridge pins. I wonder where they might be. So I'm trying to get a decent amount of light in there, but as you may be able to see, some of those cartridge pins appear to be touching on either side. That's going to cause an issue. It's going to connect address lines to other address lines, data lines to other data lines, and the CPU and a lot of the other ICs are not going to like that. They're going to get quite warm. So this could explain why the 2600 cartridges booted to asteroids. The 2600 cartridges are not working, but they're separating those pins. Let's try that out. So I've just cut up a strip of old card, and that should fit in between this cartridge slot. So that should be now separating all the pins, and with any luck, we should get asteroids, right? We do! So the problem is just with those pins touching each other. Dirty pins. That's awesome. Kind of frustrating though. I was certain that, it was going to be one of these logic ICs or the ROM, the CPU. It's just a bloody cartridge port. Okay, well, what we need to do is figure out how we can bend these pins back away from each other without destroying this thing. I wonder if I just double up on this card, that should push them away and hopefully bend them out a little bit without destroying it. Yeah. Well, I'm not sure how this plastic shroud comes off. I think I'm just going to desolder the whole connector and see if we can get it off after that. Right, I heard two where the moo sounded slightly off. A little bit dull. This one. And this one. Let's try that again. It sounds better. Ooh, this one's a challenge. That sounds better. That should be it. Just like that. Sorry about that little bit of crappy audio. The memory card on the main camera filled up, so it just stopped recording, and then I was just left with the overhead one, which has terrible audio. So yes, the edge connector is out, and while I was emptying that memory card, I looked for replacement edge connectors. Couldn't find anything though. This is kind of, I guess, custom for Atari because it's got those two tabs on either side, and it's very similar to a 36 pin. This is only 32 because we've got a few pins missing either side here. So I thought 36 pin might work, but then I couldn't find a 36 pin that had legs long enough. These are quite extended from the actual edge connector itself. So I'm not sure if there's an easy replacement for this, so I might just have to try and repair it. That should be fun. So what I'm thinking is we just pop out these pins because they should, in theory, push out, which they do. So that's one of the good pins, I guess we'd call it. That's what we're aiming for. So it looks like all the pins on the inner part have been sort of bent inwards or outwards or something, and that would match up with a 2600 cartridge because it doesn't have these edge pins like the 7800s do. So I'm guessing a lot of 2600 cartridges got jammed in here, and yeah, it's eventually messed up the pins. Huh. Maybe it's bent slightly in that way. Let's put that back in, see how it looks. Oh yeah, that does actually look better. Right, I'm going to push all of these out, see if I can just get them all straight. So finally, after a bunch of straightening pins, everything looks pretty good. They're definitely not touching. I can actually see the bottom of the connector now, and they all seem to poke out just a little bit, so they should make good contact with whatever cartridge we put in there. So the only thing left to do is get this all soldered back into the board. There it is. Make sure I put it the right way. Yes. Looks good to me. Let's try it out. That's connected, that's connected. Let's do it. Yes. Asteroids. Sweet. Let's see if one of these controllers will work. Why do I keep disappearing? This doesn't seem right. Let's try this one. Ah, that seems better. Cool. Asteroids. Let's make sure Ball Blazer still works. It is that way, isn't it? Oh no. I did put it in backwards. How about more asteroids? Oh shit. I'm gonna take the whole thing out again. Yep. Okay. Asteroids. Yes. That felt good. There it is. That little flicker was just the analog video tuner. Well, that's the Atari 7800 for now. I've done Asteroids and Ball Blazer, and they're the only two games I can play. I guess I will have a look at these 2600 cartridges. I'll also have a look at a 2600 one day, but I think for now I'm going to call this one good. I'm happy that the machine is working. There is a lot of work to do to piece back together that case, and of course I want to look at video output options, obviously composite, maybe S-video. I assume probably possible to get S-video from this thing because the chroma and luma are separate somewhere on these boards, so maybe S-video. I do like S-video. I can't stop saying S-video. Anyway, I hope you enjoyed this one. I'm really glad that I didn't go just pulling out random ICs and putting sockets in, because then I'd have two 7800s with a bunch of sockets in them because I'd have to swap chips back and forth. Sometimes it is just the, physical stuff. That's probably what I'd suggest looking for first. But, it did kind of seem to be a logic issue. It kind of made sense at the time, but yeah, always suspect physical connections first, I guess. Anyway, that is it for this one. Thank you all for watching. A huge thanks to the people that support the channel on Patreon, and if you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos, but yeah, until next time, let me know what you thought, and I will catch you in the next one. Bye. Oh, Hacko, I could kiss you, but you're covered in lead. Extremely hot though.